facilitating this. This will be about an hour-long webinar, and if you have any questions, use the questions tab in the left panel. I will send out a recording of the presentation once it becomes available to all the attendees. And that is about it. David, take it from here.
Okay. Well, good morning or good day. Thank you for joining this webinar regarding humidification systems for universities. My name is David Baird. I'm an applications engineer here at DrySteam and just interested in diving into this topic with you today. So, in thinking about universities, there's a lot of different types of buildings that are on a campus, ranging from classrooms and lecture halls to the dorms, in addition to sports facilities potentially, laboratories, performance halls. One of the common themes with all of these is it's about people. People occupy all of them. And humidification really is there to help protect the people, the processes, and the materials within each of these spaces. The conditions and what we're trying to maintain in each of these will be different, but it's a beneficial piece for all of those. And so kind of thinking about this, humidification is really beneficial for people. And since we're inhabiting each of these different spaces, it helps promote health and well-being. Dry conditions can be uncomfortable as it dries out the skin and our mucous membranes, our eyes, nose, throat. In addition to dry conditions can be favorable towards bacteria and viruses, which can lead to increased absences from students and faculty. One of the common references that we refer to with humidification is the Stirling chart, and you'll see it on your right. And what you'll see is kind of the thickness of the bar. The thicker the bar, the more favorable it is towards that specific substance, as an example. So bacteria and viruses tend to thrive in lower relative humidity or higher relative humidity. You move to that optimal range between 40 and 60% relative humidity. It's not ideal for those substances. And so that's something that we'll continue to kind of look at a little bit, but it's a great study done back in 1986 regarding humidification and the benefits towards people and health and wellness. So kind of thinking about this and just breaking it down a little bit more, just like what the Stirling chart was showing, bacteria and viruses thrive in kind of that dry air, so that lower section. And that's because you don't have as much moisture, the particle sizes get smaller. So one of the things that happens is as particle sizes, which we've heard a lot in regards to COVID as an example, a lot of aerosolized particles such as viruses or colds and flus, as they dry out, just like our skin, particle sizes get smaller, and it means that they're more infectious. They can get into our bodies easier. And research studies, besides the Stirling study, have kind of shown that correlation between low relative humidity and flu outbreaks, which is clearly in that virus category. In addition, another study kind of looked at, students and how often they're getting flu vaccines as an example to help reduce a flu outbreak. And not quite half of students generally are. So further kind of impacting the space and where those viruses and bacteria want to live and just what we're doing about it. So looking at something that doesn't require direct intervention, if we think of the current pandemic and masks and social distancing, all these active measures that we have to put in place to try and help stop the spread. Looking at something else that's more passive, such as humidification, can help kind of keep it, safe, efficient, and it's an easy way to help kind of stop that spread. That's an example. In addition, as I said, kind of talked about that particle size concept. And so if it's a drier environment, the particle sizes get smaller, then our immune system, basically the different things we've talked about, the mucous membrane, they can't help get rid of those particles as easily as well. So our body isn't able to fight it as well. And so, just it's where they want to be, and our body isn't quite as strong in that dry environment, just leads to a greater opportunity for an outbreak, whether it's between students or students and faculty, and just when humidity is low. And another study kind of showed that cold or flu-like illnesses impacted their student performance. If they're not in the classroom as much, they're not able to learn. It can be a distraction, just like being uncomfortable within a space. And, kind of continuing that concept of uncomfortable. If you're, too hot or too cold, it creates a distraction from learning. And so the time that they are in that classroom, as an example, trying to learn the subjects, taking distractions, doesn't help their academic performance per se. And, so kind of keeping that an ideal range from, not just humidity, it's one of many factors, but temperature as well is something. And so just kind of thinking of if that human body is uncomfortable, then we're going to kind of create that distraction. And, kind of focused on that absence. It's not just the students, but it's also the staff and the faculty as well. And so time away from that classroom will impact the academic performance, the quality of their education potentially. And so those dry winter months, think of a cold climate. I'm in Minneapolis as an example. And so it gets to be cold and dry. And so kind of an ideal condition, if I take outdoor air that doesn't have a lot of moisture, I bring it into the space and warm it up, then my moisture content continues to drop. So my relative humidity within the space is lower. And that's partially why we're focused much more on this low humidity range, especially in colder climates and just in general, as we build them into spaces where it's warmer, that relative humidity will be lower. And so just kind of that favorable conditions in lower relative humidity for viruses and bacteria, it increases the likelihood of flu and cold transmission and infectivity, and just kind of consider, to reducing the risk, not just in the classroom, but across the campus. And so maybe it is in the public spaces, at the cafeteria, as an example, the dormitories, maybe it's the student hall, as an example, where there's activities and people gathering. So it's kind of looking at it holistically from an entire campus, that there's a lot of different places where students will congregate, not just within the classroom, as an example. So kind of maintaining that more ideal range we're looking at from 40 to 60% would just kind of help stop that spread of these different viruses and cold particles, and also would also help with the current pandemic with SARS-CoV-2. And thinking not just about the people which inhabited all these different buildings, but it's also thinking about the materials that are placed in each of these spaces. So think of wood floors in a gym or musical instruments as an example. Wood is very hygroscopic and it changes size depending upon the amount of moisture. So if it gets really dry, then it's going to potentially lead to warping or cracking or shrinking. Not ideal for these types of equipment, and can impact them. Humidification, as an example, is commonly seen in museums where they're protecting artifacts within the exhibits. So that concept of protecting the materials within the spaces as well is an important piece. So kind of going back to the human body. So the human body is composed of about 2/3 water. And so we're sensitive to changes in moisture, but we're not very good at kind of sensing, okay, is it, in that 40 to 60% range or higher or lower? We really kind of notice the effects of too much or too little moisture in the space, much more so. We're able to protect itself under stress, but if we kind of keep it in that comfortable range, then we're going to be able to fight things better. So kind of keeping that mid-range into play, it's not just helping make us feel comfortable, our body works better, Different clinical trials have kind of shown that infections are less if you're in kind of this mid-range as well. And the infectivity, partially because of those particle sizes, or just the way our body is responding to these moisture in spaces, the particles within the spaces are also going to be impacted equally as much. And so, thinking about what are some of the benefits of having humidity kind of in that, optimal range, that mid-range. Well, you get increased productivity, kind of thinking some of the softer benefits as an example. Okay, avoiding eye strain and dry eyes, which can be, a challenge in having to use drops or dry hands and needing to use moisturizers to try and keep them feeling well. Allergies and asthma, thinking not just in terms of viruses and bacteria, but also mold spores and other things within the space. If I can breathe easier in a mid-range humidity, it continues to kind of make myself comfortable. And, if you're singing, okay, needing to get additional moisture, drinking water in order to keep yourself hydrated, really dry environment, it's going to dry out the vocal cords, potentially impacting your performance if you're doing a concert, as an example. And so kind of thinking through that comfort and how it impacts the body, not just on, those viruses and particles, as an example, or the materials within them. And so kind of building on that comfort or discomfort, specifically looking at a couple of different areas. I mentioned kind of dry skin. We'll notice it if the relative humidity is too low. Skin gets dry, maybe even cracks. And so you need to look to some other method to try and help solve that. And, discomfort to the eyes. Again, same thing of eye strain, dry eyes just creates a distraction, lack of focus in a classroom when you're trying to learn and invested in that. It's not beneficial. And also, we kind of talked about those mucous membranes, which is the eyes and the nose and the throat, and just how that can be keeping those there to help filter. That's the purpose of them. And if they're dry, they just don't work as well, which is partially where those particle sizes get smaller further into our body. We're not able to get rid of them quite as easily. And so, that low relative humidity really can be a challenge. And, specifically looking at aerolized particles and just how it interacts with them. So kind of thinking, the CDC tracks, flu outbreaks as an example. And they always tend to be flu season we think of as late fall and winter. And that's mainly because relative humidity drops during those temperatures. That case, because as I said, you've got colder temperatures, you're not able to have as much moisture outdoors. You bring it inside to the space, further drying it out because we're in heating mode. And so that's further reducing that relative humidity. And so there tends to be a trend of, a low relative humidity of 14 to 16 days later, you're looking at a potential flu outbreak as a result of it. And so thinking through what are the costs of this, there's obviously the disruption to yourself. And so thinking of it not just in terms of, the medical expense to get treated, but it's also looking at, okay, what are some of the lost earnings? So I can't go to work. If I'm an hourly employee, not be able to make it to work, that's directly impacting my income. And also thinking about, well, what's the impact of the business as well? If you're not there, is productivity reduced? Or if I do go to work and I'm just not at 100%, I'm not able to be quite as productive in the workplace. So it's not just, your medical expenses and also, your earnings if you're there, but it's also thinking about what does that do to the overall business as well. And so the economic impact of not managing, kind of this flu season as an example, can be a real burden. We've noticed that significantly through this pandemic and how it shut down different states and really impacted the economy. And so kind of thinking through that impact of, okay, if we can manage this, it's better for all within society. So I'm going to talk a little bit about a study, and there's not very many of these studies that happen out in the real world. A lot of these happen within a laboratory setting, controlled environment. Yeah, one of these studies was done here in Rochester, Minnesota, in partnership with the Mayo Clinic and a nursery school. And so Jennifer Reineman, a PhD doctoral research fellow at the Mayo Clinic, partnered with the schools here in Rochester, a nonprofit based within the Center for Clinical and Transitional Science and Department of Biochemistry and Molecular Biology. And so what she did was really looking to see how much can humidity impact the spaces where these children are, as an example. So it's a direct intervention where you have one space that's humidified, one space that's not humidified, and trying to quantify that. So the thought is that humidity would have a positive impact in terms of reducing flu transmission, the particle sizes for flu-like illnesses, influenza A as an example, both in the air, on surfaces, and also just kind of then in kids and just kind of their wellness in general and absences. So thinking about it, all of that holistically. And so again, looking at not just surfaces, okay, what do we find on surfaces? What do we find by taking air samples and looking at absences and increases of flu or cold like symptoms within the children within the space. And so active humidification was placed in a few of them and maintained at about 35% relative humidity versus 20% relative humidity for those that were not humidified. And the thought was that by increasing it to that more ideal range, that 40 to 60% or closer to it, would reduce the likelihood of seeing those influenza particles within those classrooms that were humidified. And temperature between both of them was maintained about 68 degrees. And so what the findings were that flu-like illnesses were less in the humidified room, more than half less of that. And then there was also a significant reduction in terms of samples within the air of influenza A. There was a reduction in terms of samples on the surface. And so just combining both of those in terms of the air samples and the surface samples, it did have a positive impact in reducing how many influenza A particles were present. So it moved it to an environment which was not as favorable towards viruses. Kind of going back to the Sterling chart where we showed that exact same thing. So besides thinking about the human body, it's also thinking about this concept of thermal comfort. And so thermal comfort is that condition of mind which expresses satisfaction with a thermal comfort. And there's a number of different factors that go into it, whether it's what clothing you're wearing, the temperature, how much air is moving around you, what you're doing in the space. And humidity is just one of those different pieces that goes into that concept of thermal comfort. And so if you're comfortable, again, it's not going to be a distraction from you trying to learn. And so one of the things that was kind of interesting is that by having some humidification, by raising the relative humidity, you could actually lower your temperature set point within the space. Just that combination between temperature and relative humidity can still help you feel comfortable. So maybe shifting a little bit of the energy from heating to humidification could be beneficial and still feel comfortable within the space. And so building on it, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, kind of establishes best practices for heating and cooling systems for buildings, as an example. And looking at schools, they kind of looked at, okay, for classrooms, gymnasiums, and cafeterias. And that concept of thermal comfort we just discussed, now you can directly see if you maintain that relative humidity at a higher level, you can see the direct recommendation in terms of dry bulb temperature being reduced. So by putting more moisture into the space, you can drop that temperature set point. And this just kind of shows that same thing. And so kind of see there's an ideal range for a number of these spaces. And additional building types on a university, such as a laboratory or a performance hall, would also have a slightly different range that would be recommended. And these are just kind of, it's a guide, not a hard and fast, but generally what a design engineer would be looking to try and set for the space. So we've kind of talked, there's a number of potential benefits to humidification within the space. But how do you even get started on it? And so if we want to hit this mid-range, this 40 to 60%, then that's okay. How would we do it? Well, a couple of different things. One is, okay, can we put it directly in the space? If I'm trying to control one space directly, then maybe dropping in something with a blower pack, as an example, kind of think of that top picture where I'm putting moisture directly into the space. Or maybe I'm trying to humidify a much larger space and it's multiple different rooms, classrooms as an example. It's integrating that within the air handler system, which is moving air to all the different spaces. And so just different types of considerations, and it's all application dependent. Is seeing visible vapor, steam cloud as an example, acceptable within the space? Or do I need to integrate it into the HVAC equipment? Is there space to be able to put, the humidification equipment into that air handler or into the ductwork? And so it's really kind of understanding what is happening at that space to understand where could I apply it and what are my goals? Is it just for one space or am I trying to cover a much broader section? And so besides thinking about where I might place it, a lot of times it's a focus on, well, how could I power this humidifier? And I often like to think of this in terms of what energy sources are readily available and cheapest to operate. And so if I think of it, okay, generally if there's a boiler on site for a campus, and I have some capacity, I could tap into that and I could use direct steam and put it directly into the space. If not, generally natural gas has a cheaper operating cost. And so that may be using a gas-fired humidifier to boil water. Depending upon the size of the system, if it's really small, now I've got gas piping and flue venting, a number of different things I need to connect to that may be using an electric humidifier that doesn't have as much complexity. I just need to have power available. That may be a better solution with lower installation cost, but a little higher operating cost, but allows me a lot more flexibility where I would place it within the space. And maybe it's thinking about, do I need cooling and humidification? Do I need a server room as an example? Okay, in that case, being able to take advantage of both using a different type of product, not just looking at a steam system, but a water-based system. And so that could be using atomization or wetted media. So really kind of depends on what the goals are for humidification and what energy sources are available to kind of get started with it. It's kind of coordinating with a facilities team to understand what the current infrastructure is, what are the options available, and then what's the best way to integrate this humidification system into the existing equipment. And a lot of it is getting an idea of what the current conditions are within the space, taking a hygrometer and what is the relative humidity within the space? In winter conditions, am I still in that acceptable range, or am I dropping below that 40% into that 20 to 30%? Getting an idea where you're at helps kind of guide what the decisions are going forward. And so if it's trying to hit a target of that 40 to 60%, let's just use 45%. It may be looking at, if there's already a humidification system, is it large enough in order to meet that need? Maybe it's making, adding an additional humidifier to it, or increasing the size of it, or changing the set point, that maybe on the really cold day where I'm bringing in cold, dry air, I can't meet my relative humidity I'm trying to hit, but on days which it's more mild, I can do that. And so really thinking through, how is the existing equipment set up and operating, and also what can we do to try and help address that and move it into that ideal 40 to 60% relative humidity range. And so, it's working with not just the facilities teams to understand what's there, it's also potentially working with a local agent to try and get an idea, what are the solutions available to me? Humidification, it requires water and power and a drain typically. And depending upon the types of systems, it may need a boiler or gas humidification as well. And so it's really looking at, what utilities do I have available? Where can I place it? And your local representative can help address that and review, how much additional humidification do I need to try and move to that ideal 40 to 60% range? Dry Steam is a US-based company, and we can find solutions and assist with this relatively quickly. So if you need a solution quickly to try and move to that ideal range, we have solutions available, and spanning a number of different types of energies depending upon what's needed, and performance information as well. And so, equipment's quickly accessible, available relatively quickly, and a strong partner, a number of different resources available to help identify what that humidification needs are and solutions available to try and protect that investment in the students learning as well as the faculty. And so just a little bit about Dry Steam. Dry Steam is a company committed to quality. Quality is one of those core things that we do. We make very high quality equipment. We're focused on making sure we're supporting the customer and providing superior products for humidification. We stand by the products not just from the initial start, but it's also looking at them over the lifespan. So, as an example, we talked about, if you have an existing humidifier and you need a little bit more capacity, maybe there's solutions with just modifying that piece of equipment. And there's a lot of different information. We touched on a couple of different studies that were discussed during this presentation. There's significantly more resources available on our website regarding humidification systems and what types of things to consider, in addition to real world applications where humidification has been applied to a school or to an office building or other types of locations, and the different considerations that went into that. And based on that, I know it went a little quicker. I'm open to any questions that you might have, and can go back through any of it. But really, a lot of it is kind of understanding where that ideal range is, and how humidity is just one of those passive solutions to help with maintaining the human comfort, and also reducing viruses and bacteria, which right now in the current pandemic is something that we're all reeling with. And so, any questions that you might have? Let's see here. I see one question. in regards to the building envelope and cold surfaces or glass. And so that is a great question. By trying to raise the relative humidity within the space, you have to be concerned that that building exterior, as an example, will be able to handle it. You don't want to add too much moisture into your home, as an example, and end up with moisture condensing on your windows. In that case, you've raised the relative humidity too much. And so one of the solutions to try and help address that is to have a sensor placed in an exterior wall or window, so that way you can keep that relative humidity set point below where that moisture would condense. So it may not mean being able to hit into that 40 to 60%. Maybe it's being able to make it to 35%. And so moving towards that mid-range, as an example, going back to the preschool where it was maintained at plus or minus 35%, there was still a positive impact versus the 20% in the other room. So great question. And so, raising the moisture, need to make sure that the building is designed and can handle it. And there's controls in place that you can use to help facilitate and prevent problems from happening by adding active humidification. Any other questions? Feel free to type them in the chat or in the questions, and we can address them. Otherwise, there's a significant amount more information available on the website, as I said, referring to case studies and information about how to apply humidification in order to try and determine how much humidification needs would be and what might be the right solution. Seeing none, I thank you for your time on this presentation and just thinking about how humidification can be beneficial to not just the people that are within the spaces, but also the processes that might be in the spaces and the materials that are also within those spaces. Thank you.